Hello my Genesis students. Today we are in lecture number 14 of standard 11. We are studying vector analysis. It is lecture number 14 and we are studying here the vector analysis. My dear student, we have studied so far the representation of vector, the addition, subtraction of vector, and we have started the multiplication of vector. In last lecture we have concluded with the multiplication of vector by the magnitude. Today, my dear student, we will start the multiplication of vector, and it is the multiplication of vector by a vector. Okay, and the first product that we'll study it is the dot product, that is also called the scalar product. And why it is called scalar product, we know very well. It gives the magnitude as a result. Okay, so here we go for the dot product. Dot product, this is called the scalar product. In engineering, this dot product is also considered as the inner product. Remember, my dear students, okay? As you will open the book of Beer and Johnston, then you will find it is mentioned there, it is inner product, okay? That is the very good book for study the vector. It is the Beer and Johnston, the engineering physics. Now, my dear student, for your level, remember my assignment and this particular lecture is more than sufficient, and the few questions you can use the different packages of different institutions for your practice, my dear student. Here, suppose we are having two vectors. Okay, one, it is vector A, and another vector, it is vector B. All right, those two are inclined at an angle theta. This one is the angle theta. Okay, the vector A, the vector B, the magnitude of vector A, it is the magnitude of vector A, suppose it is A, magnitude of vector B, it is suppose B. All right, now the dot product, the definition of dot product. So the dot product of two vectors A and B mathematically equals, remember students, you are writing in your notebook, mathematically it is equal to the product of magnitude of two vectors, that is mod of A times mod of B. All right, and cosine of angle between that two vectors, that is cos theta. Okay, so the A dot B can be written as A B cos theta. This is the simple thing. We don't want to make it complex. It's very simple. It is A dot B equals A B cos theta. All right, yes. Now if there is a question in your mind coming, so what will happen if we'll make a dot product with B dot A? Yes, so let us look here, the B dot A, B dot A. So according to this definition, you have to write the magnitude of B into magnitude of A into cosine angle. Now what is the angle between this B and A? So if you are going from A to B, then of course this is theta. If you are going from B to A, so this angle will be minus theta. Remember, it is minus theta. Or you can study this angle in this way as 360 minus theta. Am I right? Yes, it is 360 minus theta. So you can use any 1, either 360 minus theta, or either you can use directly minus theta. So let me write here the minus theta. Now b dot a, it is a b, that is the magnitude of a and b. Cos minus theta, how much? It is plus cos theta. So you can see, my dear student, a dot b, it is ab cos theta, and b dot a, it is also ab cos theta. So there is no difference between a dot b and b dot a. This is called the commutative law. It is a dot b can be written as b dot a. Must remember. Alright, my dear student, b dot a can be written as the a dot b as well. Okay. Now we are going to find here the dot product of unit vector, because that particular thing will help you for solving the numerical. Okay, so the dot product of unit vector, dot products of unit vector. All right, now the dot product of unit vector, my dear student, here you can see, suppose this is the unit vector. Here the small diagram is representing the unit length. Okay, this is I cap, j cap, and this is k cap. All right, yes, are the perpendicular to each other. What will be the angle between I and j? If I'll ask, then you will give me the answer. Yes, it is 90 degrees, sir. What is the angle between j and k? Again, it is 90 degree. And what is the angle between k and I? Again, it is 90 degree. So there is an angle 90 degree between each of two axes. All right, yes, my dear student. Now we are going to find here the dot product of unit vectors. Okay, now my question is, what will be the value I dot I? Okay, I dot I. So here, sir, mod of I into mod of I, because the two vector is nothing but the I dot I. Now cosine of angle between 2i, both the I cap is in the same direction, so the angle will be how much? It is 0 degree. Let me write here the 0. Mod of I, do you remember? Yes, it was 1. I have told you in last class, magnitude of any unit vector must be 1. So it is 1 into cosine 0, it is again 1. So this will be the 1, remember. So the I dot I 1. In same way, if I dot I is 1, in same way j dot j will be also 1, and k dot k will be also 1. You can solve it is by yourself. All right, my dear student. Now the next one, what were the results, sir? I dot j. Yes, I dot j. Try to find out by yourself, my dear student. Here the mod of I into mod of j into cosine of angle. What is the angle between I and j? It is 90 degree. So this will be the 0. Why? Because cos 90 will be 0, and this is 1. So the 1 times 0, it is 0. So all the vector, if two vectors are perpendicular to each other, then dot product of that two vector must be 0. Do you remember what we used to say, the two vector which are perpendicular to each other? Yes, that are the, yes, which type of vector? That are the orthogonal vector. So the two orthogonal vector always gives dot product must be 0. Remember, here the Ij can be considered the orthogonal, okay, orthogonal unit vectors. Okay, my dear student. Now let me proceed for the next. So this is all your dot product. Okay, nothing very much you have to study. Now we have to do some practice. Okay, let me rub this. Remember, I dot I, it is 1, I dot j, it is 0, j dot k, it is again 0, k dot I, it is again 0. Sir, what will be the result if we are having, here we go with the example, if we do I dot a dot a, what will be the answer? A dot a, what will be the answer? Then you need to ask first, so what is the magnitude of a exactly? So suppose, okay, so suppose the magnitude of a is a itself. We'll write here the magnitude of a, and then cosine angle, how much it is? 0, because we are having the two similar vector, and it will be the a into a, this is the a square. Remember, my dear student, so the a dot a, always it will be equals to the a square. All right, okay, what will happen if we'll do the dot product of two vectors? Look at here, a plus b, the two vector, dot a plus b, what will be the result? If you want to write here, these are the two vectors. If you want to write here a plus b square, okay, it is okay, a plus b square will be there. But you cannot break this a plus b square simply using your ordinary algebra, a square plus b square plus 2ab, that's it. No, you cannot. All right, because we don't have the angle between this a and b. So suppose the angle between a and b is theta. Okay, here the theta is the angle between a and b. Suppose it is given. All right, the angle between a and b, it is theta. This is theta. Then what will be the result of a plus b dot a plus b? If you are writing this a plus b dot a plus b as vector a plus vector b at the whole square, then this is not wrong. Yes, it is correct. But what will be the next? You will be very confused of solving this one. So let we start the dot product of this one only. Here, start one by one. A dot a, that we have studied in standard 8th and 9th. A dot a. This is starting, that's why I'm dealing here in very slow speed and in very detail I'm teaching you, my dear student. Once you will get all the things, my speed will be like I got the nitrogen gas. A dot a plus a dot b, all other vector, remember, plus b dot a plus b dot b, now the result. What is a dot a? Right now we have studied here the a square. Yes, a square plus a dot b, here the angle theta between a and b, so it will be the ab cos theta. Okay, ab cos theta plus what will the b dot a? We know that a dot b and b dot a both are same, so ab cos theta again, and b dot b, it will be the b square, so it is a square plus b square plus 2ab cos theta. Okay, so this is the a square plus b square plus 2ab cos theta. Do you remember we got this type of result somewhere? Yes, this is the resultant magnitude. Okay, this is the magnitude of the resultant in which we used to add two vectors. Okay, vector a and vector b, and the angle between vector a and vector b, it was theta. All right, okay, now this is your homework, you can do by yourself. A plus b dot a minus b, what will be the result? Okay, this is your homework. A plus b dot a minus b, this is your homework. Now let me do some practice and then we'll start the application of dot product. Okay, here this is our classwork, and after that I'll give you homework on the basis of this one. Okay, you are in a market of vector, you are having number of vector here, I plus j, I can write anything, b, it is I minus j, c, it is I plus j minus k. Here d, it is 2i minus j plus 2k. Okay, e, it is 2i minus k. All right. Okay, this is other sort of vectors. All right, now we have to start the practice question. Find dot product of following vectors. Now the first question, what is the question actually? Find dot products. Wow. Okay, the first question. A dot B. Okay, so this is the first question. Let me solve. After that you will solve by yourself. I minus j dot I plus j minus k. From where you got this vector, sir? Actually it is given here, my dear student. Okay, I minus j dot I plus j minus k. Okay, I dot I, you can see I dot I, it is 1. I dot j, it is 0. No need to write. I dot k, it is again 0. No need to write. J dot I, no need to write. It will be the 0. Minus plus minus j dot j, it will be 1. And j dot k, it will be 0. So the required answer it is 0. Okay. Now you got. My dear students, you can do this calculation very fast. How? You know that this I will give the result only with the I, and this j will give the result only with the j. So you no need to do the multiplication with all the ijk. Okay, just do the multiplication. Try to find out if it is I, where is I is okay. Now if it is j, then try to find out j. It's okay. So j and I give the result, nothing else. Now the next question I'm giving you, you have to do the next one. It is the second. Now I'm preparing the question by all the possible multiplication. Okay, you are the science student. As I told you, what are the permutation combination? AB, AC, AD, AE. Okay, then BC, BD, BE, then CD, CE, then DE. So all the possible combination you have to form and do your practice. What will be the next? AB we have done. So AC, A dot C. Okay, tell me the result. Till I'm just clearing the board, kindly do this. A dot C. What will be the result, my dear student? A dot C. Okay, one more question. Let me solve. Okay, A dot C. A dot C. A, it is J plus, sorry, I plus J. I plus J dot C. C, it is I plus J minus K. All right. Now the result. I dot I, this will be the 1. I am not going to multiply with all 1. All right. J here and J here plus 1. So the answer is 2. Now homework. I have solved 2. Okay. Kindly note down the homework. Okay. In very speed I am telling you. A dot A dot B I have solved. A dot C I have solved. Now your homework. Starting A dot D, A dot E, B dot C, B dot D, B dot E, C dot D, C dot E, D dot E. Okay, so this much is your homework you have to do. All right, so this was a very simple practice. Now one more question, my dear student. Suppose if you are having a vector, and if it is telling the two vector, all right, like this way. vector A, it is 2i minus j plus 3k, and the vector B, all right, it is I minus 3j plus x, sorry, plus it is lambda k. Okay, it is lambda k. We don't know the value of lambda, it is unknown. If these two vectors are orthogonal, then find lambda. Okay, if these two are orthogonal, then what will be the value of lambda? This is our beautiful question. Now, what will be the answer? You have to find the value of lambda. Could you solve? Yes, you can solve, my dear students. How? We know that if these two are orthogonal, then A dot B, oh my god, A dot B must be how much? It is 0. You know, orthogonal, it means the two vector having the angle, how much? It is 90 degree. So A dot B will be 0. Now do the dot product and try to find out the value of lambda. So the 2i minus j plus 3k dot I minus 3j plus lambda k, and it should be how much? It equals to 0. Now 2 into 1, 2. Now minus plus 3j, all right, and plus 3 lambda is equals to 0. So it is 5. 3 lambda is equals to 5, sorry, minus 5, no? So the lambda, it will be minus 5 by 3, answer. If you will try to arrange this vector, you will find vector B as I minus 3j plus, sorry, minus 5 by 3k. Okay, so in this type of question you might be encounter. All right, one more question. This question actually I'm telling you, it is mentioned in some book, but this is not very great question, my dear student. I always try to explain the student, but this type of question, it has been given in books, so you have to solve this one. It is written, if A is a unit vector, A is a unit vector given by A is equals to 2i plus lambda j minus 3k, it is given. Then find the value of lambda, it is given, okay, in books. Find value of lambda. If it is unit vector, then find value of lambda. So how we will do? Of course, if it is unit vector, then magnitude of this vector should be how much? It is 1. Mod of A should be 1. This is not the great question of dot product. So you will find the magnitude of this one equating as 1. So you will get root under, all right, 2 square, that is 4, plus lambda square plus minus 3, that is the 9, and it is how much? Equals to 1. So this will be the lambda square, squaring both side, okay, it is minus, you can see this is not possible imaginary thing you are going to get here. Lambda square, it will be 13. So could you find the value of lambda, my dear student? This will be the root under minus 13, and this will give you the imaginary. The root under any negative thing will be the imaginary, that is with the iota. All right, so you can write this one, minus root under 13. All right, okay. Now here we will start the first application of dot product, and in next class we will study in very detail. Okay, give the heading application of dot product. The first application, projection of one vector along another. Projection of one vector along another. Okay, suppose you are having a vector like this way, the vector A, and this is the vector B. Okay, you know that angle between these two vectors is theta, but we don't have very much use of this theta. You have been asked to find the projection of B. Projection of B. Remember what I'm telling you. Projection of B along A. Along A. You have to find the projection of B along A. So the projection, it means the component. If you try to break this component along this axis, that is along the A, you will find of this much length. Of course, this will be. And what will be the if the magnitude is B, then what will the value, that is the component of this one, it is B cos theta. We know that B cos theta. It means what we have to find, this B cos theta we have to find actually. Okay, if you have been asked to find the projection, it means you have to find this B cos theta. All right, yes. So if this projection is a vector quantity, it means this projection will have the magnitude of this length and the direction will be, it is same as the direction of A. So to find the projection, we are going to do here the dot product A and B. So the A dot B, it is how much? AB cos theta. And what we have to find? We have to find this B cos theta. You can see it is B cos theta. So the B cos theta can be written as A dot B divided by A. Yes, this A dot B divided by A. This is the B cos theta, and this is nothing but the projection of, remember, this is the projection of B along A. B cos theta is considered as the projection of B. B cos theta is the projection of B, and A cos theta will be the projection of A, and the rest axis will give you on which you are finding. So this will be the very easy A dot B. Now this projection, that is the B cos theta, you can also write, remember this vector A divided by A dot B, we can write, yes, we can write, this was the dot product, we can write. Now this B cos theta is equals to, we know that if we divide any vector by its magnitude, we got the unit vector A cap vector B. Okay, so this is the formula, but remember, you are not going to use this formula. You have to find the projection by the particular method. You can do the multiplication. You don't need any ready-made formula for everything. Sometime in physics, okay, or in science, you always try to find the formula, try to derive the formula for yourself. Never find, okay, ready-made formula everywhere. Okay, my dear student, try to look at here. Since this B cos theta is the projection of B along the A, that's why along the A, remember, what will be the final direction of this B cos theta? It means the projection of B. What will be the final direction? Of course, is the final direction as the A is having. It means you will have the final direction as A. That's why here the direction of A. What is the unit vector A? Unit vector A is nothing but the direction of A. So the A dot B. You have to do the A dot B. Directly for the shortcut you can remember. Now the very simple question. If A is given like 2I plus J. Alright. And you have to find the projection of A along the vector B. It is I minus J. I minus J. Okay, then what will be the result? So along B, but you have to find the position of A. So you have to find A cos theta. Remember, and it will be A dot B divided by magnitude of which one? You have to find the projection of A cos theta. A cos theta, projection of A you are going to find. Projection of A, it means you will have the direction of which one? B. So it will be the B downward, the magnitude of B. Now it is very easy, my dear student. So you can write here. If you forget this concept, which we have to do the dot and which will we have the magnitude, so simply you can draw the diagram here. Find this diagram will work everywhere. A B. All right, this is the theta. Here in question, find projection of A along B. Projection of A along B. So this will goes to break over this axis. All right, so the A cos theta you have to find. Okay, A cos theta you have to find, and then you will write A B cos theta as A dot B, and you have to find A cos theta. Then it will be the A dot B divided by B. Look at here, A dot B divided by B. Okay, in same way you can write. You don't require to remember all the things. Remember, always use your IQ, your brain. So A dot B, here the A dot B, it will be 2I plus j dot I minus j divided by magnitude of B. Here the vector V, it will be the magnitude as the root under 2. Root under 1 square plus 1 square. Now, what is the result, my dear student? So you can see the result. It is the 2 minus 1 divided by root 2. So it is the 1 by root 2, and this is the answer. Okay. I'm giving you some homework to find the projection. Let me erase this one. Okay, here, homework. Let me prepare here the vector 2y minus 3j. All right, B, it is k minus 3i. Here the C, 3j minus 2k d I plus j plus k. Okay, first question, find projection of, you are writing, my dear student, find projection of A along B. Okay, second, find projection of A along D. Find projection of, third question, find projection of B along C. All right, fourth question, find projection of D along B. All right, so these are the 4 questions using the projection of vector. This was the first application. Okay, in next lecture we will start the second application of dot product, and we will also study the cross product of 2 vector. Okay, my dear students, this is all about the today's lecture. My dear students, if you find any calculation mistake, let me know in comment section so that I can rectify. Thank you very much, students.